types of functions on the basis of their mappings. Types of functions on the basis of their on the basis of their mapping. So we will have four kinds of function on the basis of their mapping. One is many one function. The second will be one function. The third one will be into function, and the fourth one will be onto function. So we'll see these four kinds of functions which are defined on the basis of their mapping. So let us consider function f from set A to B. You know that set A is the domain set of the function and set B is the codomain set of the function. So let us show the mapping as we have shown. Let us consider this is set A and this is set B. The elements, let us say A, B, C, D. Then here the elements are E, F, G, H, I, something like that. So we are considering many one function right now. So many one function means two or more than two elements in set A, that is two or more than two elements in the domain set will have same image in the codomain set. So see here the image of A is E, the image of B is E, the image of D is E. So the image of three elements in set A, that is the domain set, is same in the codomain set. These type of functions are called many one functions, where two or more than two elements in set A, that is a domain set, have same image in the codomain set. So let us take one more example. We'll try to make it more clear using this 1 2 3 4. This is 5 6 7. Let us suppose that this is set A, this is set B. The A is domain set, B is codomain set. Now 1 is mapped with 5, 2 is mapped with 6, 3 is also mapped with 6, and 4 is also mapped with 6. So here the image of 1 is 5, the image of 2 is 6, the image of 3 is 6, the image of 4 is also 6. So you can see that three elements in set A has the same image in set B. So these types of functions are called many one functions. Now we will come and see what a one function is. One function. So let us see that this is set A and it has A, B, C, D, and this is a set B where it is 1 2 3 4 5 6 and so on. So in one function, each element in set A will have a distinct image in set B. That is, no two elements in set A can have same image in set B. Then this is called a one function. So element A has different image, element B has different image, element C has different image, element D has different image. So if the function is in this kind that each element in set A has a distinct image in set B, that is, no two elements in set A can have same image in set B, then this type of function is called your 1 1 function. If you see, A has been mapped with 1, B has been mapped with sorry, A has been mapped with 1, B has been mapped with 2, C has been mapped with 3, D has been mapped with 4. So you can see that each element in domain set is mapped with a different element in codomain set. So this type of function is called a 1 1 function. Now we will move forward and see what is an into function. Into function. Now, similarly, let us suppose a function from A to B, where A is the domain set and B is the codomain set. And so, let us suppose this as set A and the elements to be 1, 2, 3, 4, 5. And let us suppose this to be set B, which has the elements A, B, C, D, E, F, G, and so on. So when we map the elements in set A, that is a domain set, with the elements in set B, that is the codomain set, then it so happens that some element in your set B remains unmapped. You have to have a clear understanding that some elements in set B remains unmapped, then such a function is called an into function. See, when we are mapping elements in set A with elements in set B, then some elements in set B, that is the codomain set, remains unmapped, and this is what is called an into function. So if you see, element 1 has been mapped with A, element 2 has also been mapped with A, element 3 has been mapped with C, element 4 has been mapped with D, and element 5 has been mapped with E. If you see which elements in set B are left unmapped, then they are B, F, and G. These three elements have no mapping in the corresponding A set. So if this is the condition that some elements in set B remain unmapped, then that function is called an into function. You will have to make it clear that some elements in the codomain set remains unmapped, then this is called an into function. So what is an onto function? You would have guessed by now. Onto function. Onto function is such that let us draw sets A and set B. Let us call it A, B, C, D, and here let us call 1, 2, 3. So let us start mapping. A has been mapped with 1, B has also been mapped with 1, C has been mapped with 2, D has been mapped with 3. So in such a function, no element in set B, that is the codomain set, remains unmapped. So no element in set B remains unmapped, and if this is the condition, then this is called an onto function. When all the elements in set B, that is all the elements in codomain set, gets mapped with the corresponding element in set A, then this is called an onto function. So each element in set B should be mapped no element can remain unmapped. So if we see A has been mapped with 1, B has been mapped with 1 again, C has been mapped with 2, and D has been mapped with 3. So see, each element 1, 2, 3, each of these 3 elements in set B has a corresponding mapping in set A. This type of function is called onto function. Now one very important function which has been derived from these functions only is 1 1 onto function. 1 1 onto function. This means that the function is 1 1 also and onto also. So what? Let us draw two sets, set A and set B. Now let us represent the elements A, B, C, D, and in set B let it the elements be 1, 2, 3, 4. So what is the condition for a function to be 1 1? So here let just see a 1 1 function. Each element in set A should have a distinct image in set B. That is, no two elements in set A can have same image in set B. This means that every element in set A will have a distinct image in set B, and no two elements in set A will have same image in set B. And what is onto function? Onto function means every element in set B should be mapped with some element in set A. So 1 1 onto function becomes each element in set A should have a distinct image in set B, and every element in set B should be mapped. No element in set B should be left. So let us do that operation. 1 is mapped with 1, B let us map with 4, D let us map with 3, and C let us map with 2. So you can see that every element in set A has been mapped with a different element in set B. A has been mapped with 1, B has been mapped with 4, C has been mapped with 2, D has been mapped with 3. So each element in set A has been mapped with a different element in set B, and all the elements of set B, all the elements of set B have been mapped. No element is left unmapped. Such a function is called 1 1 onto function, and this 1 1 onto function is very important. And when we'll see the inverse of a function, then we will see that we can have inverse for only those functions which are 1 1 and onto. So we can draw some observations from these functions, and let us discuss the first observation, that for an onto function, see, this is your onto function. So for an onto function, codomain is equal to range. All the elements in set B have a corresponding mapping in set A. So all the elements have been mapped. This means that the codomain set is actually the range set itself. So for an onto function, codomain set is same as the range set. So if you have to prove that some function is an onto function, then what you will show that the codomain set is the same as range set. Generally, the range is a subset of codomain, but here the range and codomain sets are the same. So if you have to prove that some function is an onto function, then you'll have to show that the codomain set and range set are the same. Similarly, if you have to show for a one function, so one function is each element in A should have a different image in B. So this means that if we consider f of x equals to y, then for one x there should be only one y. So if we consider this function f of x equals to y, then for one x there should be only one y. We cannot have one y for 2x. So let us consider these two curves. Let us consider this curve and let us consider this straight line. So you can see that for this x, the value of y will be this. Let us suppose to be x1, this is y naught, and similarly for this x, let us say x2, the value of y is again y naught. So x2 and x1 are the elements of your domain and y naught is an element in range. So you can see that x1 has been mapped with y naught and x2 has also been mapped with y naught. So two elements in the domain range have same image in the codomain range. So this is not a 1-1 function. This is not a 1-1 function. But if you see this image, then for every value of x, there is exactly one value of y. For every value of x, we have exactly one value of y. So if you have, let us say this is x1, this is x2, let us say this to be x3, this is y1, this is y2, this is y3. So if you see x1, x2, x3, y1, y2, y3, so x1 has been mapped with y1, x2 with y2, x3 is with y3. So you can see that each element in set A has a different mapping in set B. So this is a 1-1 function. So you can draw a conclusion that if a function is 1-1, then it must be either strictly increasing function or strictly decreasing function. I hope you'd have come across these terms while having basic mathematics course. So a strictly increasing function is one which always increases when we increase the value of x. So let us say that this is a function. So you can see that as we increase x, y also increases. So with an increase in x, there will always be an increase in y. So this is a strictly increasing function. And for a function to be 1-1 function, this should be strictly increasing. And so this is a strictly increasing function. Strictly increasing function. So this is a 1-1 function. You can see it yourself that this is a 1-1 function. For every value of x, there is exactly one value of y. So this is a 1 1 function, or it can be a strictly decreasing function. This means that when we increase x, it y will decrease. So such function can be, you can take this function to be such function. See, when we are increasing x, your y is going down. So this, in this case, you can see that when x is being increased, y is going down. So this is a strictly decreasing function. And if you see carefully, this is also a 1 1 function, because for every x there is exactly, for every x there is exactly 1 y. So this is a 1 1 function. So you should note it down that for 1 1 function, the function should be either strictly increasing or strictly decreasing. Strictly increasing means when we increase the value of x, the value of y should also increase. And decreasing function is when we increase the value of x, y should always decrease. So these are the a few basic observations. If we have a question and we have to show that this is a 1 1 function, then we'll have to find that, then we'll have to show that it is either strictly increasing or strictly decreasing. So if the function is a differentiable function, you will see these things. But for time being, just consider it. If the function in consideration is a differentiable function, is a differentiable function, and f dash x is always greater than 0, then such a function is strictly increasing function. Okay, so when you have to show that a function is strictly increasing, you can show that its f dash x is always greater than 0. Similarly, if a function is, if the function is differentiable again, and f dash x is less than 0, then such a function is strictly decreasing. So in order to show that a function is 1 1, we need to show that the function is either increasing or decreasing. So in order to show that a function is 1 1 function, we need to show that it is either strictly increasing or strictly decreasing. This means, so we'll have to show that f dash x is either greater than 0 or f dash x is strictly less than 0. If any one of these conditions is met, then we can say that it is a 1 1 function. Either f dash x is greater than 0 or f dash x is less than 0. If we get any of these two conditions, then we can say that the function is a 1 1 function. So let us take an example. Let us take a very simple example, y equals to e to the power x. Now f dash x, this means differentiation of y with respect to x will be d e to the power x upon dx. This comes out to be e to the power x only. So you can see that e to the power x is always positive. It cannot be negative for any value of x. This means this means that your dy by dx will always be greater than 0. That is, f dash x is always greater than 0. Thus, e to the power x, this function y equals to e to the power x, is a 1 1 function. Now, what about y equals to e to the power minus x? So when we differentiate it, dy upon dx, this gives d to the power minus x upon dx. This gives negative e to the power minus x. Now, e to the power minus x will always be positive. Irrespective of the power, this exponential function is always positive, and there is a negative sign in front of this positive number. So this whole number is a negative number. So dy by dx is always less than 0 here. This means your function is a decreasing function, and either the function is increasing or decreasing, it is a 1 1 function. So y equals to e to the power x is y equals to e to the power minus x is also a 1 1 function. Let us take some more questions. Examine whether y equals to 1 upon 1 plus x square is a 1 1 or a many one function. We have to examine whether this function is a 1 1 or many one function. So what we will do, we will differentiate this function with respect to x. What this will give us? This is actually d upon dx into 1 plus x square to the power minus 1. We know that in such cases we do use chain rule. So what we can do, I'm trying to get to the basics to show you all these things, but I hope by now you would have some familiarity with differentiation, because this is one of the first courses which is taught when you get into class 11th, so that you can solve the physics questions. This is the chain rule. We'll first differentiate 1 plus x square to the power minus 1 with respect to 1 plus x square, and then we'll differentiate 1 plus x square with respect to x. So what will this give? This will give negative 1 plus x square to the power minus 1 into d of dx 1 plus d of dx x square. So this comes out to be minus 1 upon 1 plus x square whole squared, and this comes out to be 0 plus 2x. This gives us negative 2x divided by 1 plus x square to the power 2. So we have our f dash x equals to negative 2x upon 1 plus x square to the power 2. So you can see that f dash x is not always greater than 0 or not always less than 0. If x is greater than 0, then f dash x is less than 0, because we have a negative sign. This is a positive quantity. This denominator is a positive quantity because it is a squared term, but the numerator is not squared, so it may be positive or negative. So it will be positive when x is less than 0, and it would be negative when x is greater than 0. So f dash x is not always either positive or negative. This means f dash x can have values of positive also and negative also. So f of x is not a 1-1 function. So if you see, for x greater than 0, your f dash x will be less than 0, and for x less than 0, f dash x will be greater than 0. So we can show that for x belongs to your real number, this function f of x is not a 1-1 function. But if we see one thing, if we consider piecewise, means for x greater than 0, this f dash x is always less than 0, and for x less than 0, this f dash x is always greater than 0. This means कि for x greater than 0, we can say that the function is a 1-1 function, because f dash x is always less than 0 for x greater than 0. Similarly, for x less than 0, f dash x is always greater than 0. So we can say that for x less than 0, the function is a 1-1 function. But for entire domain, that is for x belongs to real number, that is for x from negative infinity to positive infinity, we cannot say that the function is a 1-1 function, because the function is changing sign at x equals to 0. So this function is a piecewise 1-1 function, we can say. That is, for x greater than 0, this is a 1-1 function. For x less than 0, this is a 1-1 function. But for the entire domain, that is for negative infinity to positive infinity, this is not a 1-1 function. So this is how we try and solve and show if a function is 1-1 or a many-one function. So we will have more questions on this when we get to our question solving sessions. So for now, I think you'd have got an essence of what a 1-1 or a many-one function is. Now we'll get into other topic of function, that is a composite function, and then we'll see inverse of a function and some functional properties, and then finally we'll get into question solving mode, and then we'll have some rigorous question solving sessions. So thank you.